and Industrial Wireless Sensor Networks, ASIS. I will present approach, plan, and status report of the project so far. My supervisors are Professor Matthias O'Neils and Mr. Muhammad Imran. Outline of the project is research question, which is motivation basically, in sensor processing, architectural modeling tools, modeling framework for the design exploration, and then at the end there is conclusion. Research question is, which is the motivation of our project, is how to develop a model for a design space exploration that is evaluating different sets of solutions with quantitative analysis. Our approach is we explore in-sensor processing in the context of wireless sensor and actuator network. In sensor processing, we apply efficient division of computational load between sensor and actuator nodes and analyze their effects on energy, performance, and complexity. We need to explore architectural modeling tool that can investigate the effect of functionality movement for mentioned parameters in automatic way. So architectural modeling tools, architectural description languages are described here. Some features of AADLs are given. So we have 4 AADLs like AADL, UML, SYML, and MATA. So different features like scope, architectural coverage, tool support, extraction mechanism, limitation, computational complexity, power estimation, and latency are given. So the tool support for AADL is open source, and it supports most of the features we want to calculate for a wireless sensor network. So that's why we choose AADL. So a test case model in AADL is given. Here you can see only actuators, carbon dioxide actuator, temperature actuator, water sensor, and the water heater and heat sink and water pump. So these are different devices which is a part of a network. So here it is the implementation of this network in AADL. So we are able to estimate different parameters like power, latency, and data rate of the network. So modeling framework for design exploration is given. What we are doing is we first of all we define processes, actuator sensors in AADL as you see previously, and then we generate an XML file. It may be generated from a system generator or maybe generated manually, and from that we do the modeling of the system. Once we have the input, we can model communication model, and we can implement communication model, energy constraint, energy model, and processing model. From finding optimum solution from the modeling tool, then it's further implemented in AADL using the optimum solution of data rate, energy, and latency. And the architectural hardware architecture implementation is done maybe in FPGA later on. So in conclusion, we have developed a processing model, and we have also communication model has been developed, and energy constraint has been added. So the work in progress is testing modeling framework for complex scenarios and the implementation of the model in AADL.